Okay, so let's look at example number 2. We've got it on the table, and there's a question there. It says, how will you know if a table represents a function? Well, first of all, you got to remember back in chapter 1, we talked about identifying a function looking at a table. Do you remember when we talked about the husbands and the wives and how your X values are your wives and your Y values are your husbands, and how you always have, one husband for every wife? You remember that? So when you're looking at your table, you've got to make sure that you don't see any of your wives or your X values doubling up. All right? Now, the reality is, if we're going to give you a word problem or an application problem that involves a table and we want you to graph it, more than likely it's already going to be a function, so you don't have to check that. All right? So when we look at example 2, they have a table there that is recording low temperatures in a city in Texas. This is the way your table is set up. Now, the only difference between this and example 1 is that your table is going horizontally. But you've got to know which one of these values represents your X and which one represents your Y. Which one is your independent variable, which one is your dependent variable. Okay? Well, usually, this is another tip, when they give you information in a table that's real data, in a word problem or an application problem, your first column or first row in this situation is usually your X values. They always come first. So I'm going to go ahead and say this is my X and this is my Y. All right? Now, if you don't like the way we have our table laid out this way, because you know you're going to have to plot the points, there is absolutely nothing wrong with taking your table and just rewriting it vertically. So this can be my day in February, and this can be my record temperature. You're still going to have X for your days and Y for your temperature. Okay? You haven't changed anything, but you may want to see that because it's easier. Okay, so we've got 7 days because it says that you're recording the information first for a week, the first week in February. So we have day 1, 2, 3, 4, 5, 6, 7. And you don't have to worry about a function rule here. This is data that has been collected. We're not going to have to get your Y from an equation. So you just need to add your Y values. On the first day, it was negative 11 degrees. Day 2, negative 8 degrees. Day 3, positive 8 degrees. Day 4, 19 degrees. 5 is 20 degrees. 6 is 22 degrees, and 7 is 25 degrees. So for a week, it was pretty cold, but every day, if you can look at your data, it warmed up just a bit. So you're going to take your XY coordinate. You got one there again. If you don't like it, just redraw another one. But because we're using real data, I need you to label your axes. My X is my days in February. So these are my days. My Y, that's my temperature. Now, let's use some common sense. Days are positive numbers. So we are working with this side of my axis. As a matter of fact, I'm going to have to make this a little bigger, see how far I can go over here. Because I've got 7 days that I'm going to have to graph. I need a little more room. So day 1, day 2, 3, 4, 5, 6, 7. Then, if you look at your temperatures, you've got both negative temperatures and positive temperatures. And they range. Look at this range. So when you're looking, and I can go ahead and say that's 1, 2, 3, 4, 5, 6, 7. When you're setting up your y-axis, we're going to have to number some things a little bit. I say we number, let's do twosies. So this is negative 2, negative 4, negative 6, negative 8, negative 10, negative 11. Okay? So then that'll cover my 2 negatives here. And then for our positive temperatures, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So I'm going to stop the tape and let you finish this on your own. I'm going to bring the tape back with mine already graphed to see if our graphs match, and then we'll talk a little bit about your homework.